Hi there, welcome to my channel. In this video, I'm going to discuss about a solution for adding 1 to a large integer that is represented by an integer array. Let's look at the problem description. We are given a large integer represented by an integer array digits where each digit of I is the ith digit of the integer. And the digits are ordered from most significant to least significant in left to right order. And this integer does not contain any leading zeros. And we have to increment the large integer by 1 and return the resulting array. Let's look at the example 1. So we are given the digits array as 1, 2, 3. When we add 1, this array will become 1, 2, 4. So we start adding from the least significant digit which is present at the end of the array. Okay. Because this addition does not result in carryover, we just get only 1, 2, 4. And in the case of example 2, we add 1 to the least significant digit, then we get 4, 3, 2, 2. In the case of example 3, we have the least significant digit is 9. When we add 1, it becomes 10. So the carry will be added to the beginning of the array. So we have to basically update the current digit and then add the carry to the array. So we get 1, 0. The constraints for this problem are the length of this digits array is ranging from 1 to 100. And each digit's value will be from 0 to 9. And the digits array does not contain any leading 0. Let's look at the approach to solve this problem. We are given this input. The digits array has 2 elements which is 9, 9. So when we add 1 to this number, so we begin with adding 1 to the least significant digit, and then that result will be divided by 10. And if there is a quotient, that will be assigned to the carry, so that gets added to the next digit. The remainder will be assigned to the current location. So we repeat this until we reach the most significant digit. So in this case, we first add 1 to this 9. We get 10. The remainder will be assigned to this digit and the quotient will be assigned to the carry. So that carry will be added to this digit. So we get 10. Again we divide that sum by 10 and the remainder will be assigned to this digit. And finally we check whether the carry is equal to 1. In that case, we add 1 to the beginning of the array. Basically we create a new array, add 1 and the remaining values in the digits array. In this case we have 0, 0. So finally we get 1, 0, 0, which is 100. That's what I have listed here. First we initialize the carry to 1 and initialize the index to last digit of the input array. And we add the carry to the element pointed by that index, and then we divide the result by 10. The remainder will be assigned here to the current location, and the quotient will be assigned to the carry variable. In the next iteration, we add next element in the array with the carry. We repeat this process until the index is less than 0. After we come out of the loop, we check whether the carry is 1. If so, we prefix the 1 to that array and return the final output. So if the carry is equal to 1, we prefix 1 to the digit slice, whatever we have, and return. Let's look at the flowchart. Input for this procedure is digits array. First we initialize the carry variable to 1 and the index to point to the last digits of the input array. Then we enter the for loop. There we check whether the index is less than 0. If so, we break out of the loop. Otherwise we enter the body and we add the current carry value to an element at index idx. Then we divide that sum by 10 and assign the quotient to the carry variable and assign the remainder to an element at index idx. Then we decrement the index. We repeat this process until the index is less than 0. Once we come out of the loop, we check whether the carry is equal to 1. If so, we add 1 to the out slice and then append all the elements in the digits array, and finally we return the out slice. If there is no carry, we assign the digits array to out slice and return the out slice. Let's move on to coding. First I initialize the carry variable with 1 and then I write the for loop and start processing the element from the end of the array. So I initialize the index I to index of the last element. Each iteration I add the carry to the element present at index I. And then divide the sum by 10 and assign the quotient of that division operation to the carry variable, and the remainder value will be assigned to the current element at index I. Once we come out of the loop, I check whether the carry is equal to 1. If it is 1, I create a new slice beginning with value 1 and append rest of the elements in the digits array. Otherwise, I return the digits array as it is. Next, I am going to run the test cases. All the tests passed. Next, I am going to submit this program. Cool. This program is accepted. Next, I am going to do the code walkthrough with sample input. Let's do the code walkthrough for this input. So the digits array has 9, 9 and the expected output is 1, 0, 0. First we initialize the carry variable to 1 and then we start adding that carry to the element present in the least significant digit, that is the end element present at the end of the array. Okay, so we initialize the sum variable by adding the current digit and the carry. So in this case current digit is 9 plus 1, so we get sum 10. Then we divide the sum by 10 and assign the quotient to the carry variable. So in this case carry will be 1 and the remainder is assigned to the current digit. So the digit of 1 will become 0. Okay, the iteration 1 the index is I is 0. So we process the most significant digit and we add the carry 1 to this digit. Okay, so we get 10. Then we divide that by 10 and the carry is 1. So we assign the carry and the remainder will be assigned to the current digit present at index 0. So the remainder is 0. So we have 0 and 0. And once we come out of the loop, we check whether the carry is equal to 1. If so, we add 1 to the out slice and then add all the digits. Okay, so the output array will be 1 0 0. That is an expected output. Next, I'm going to do the time and space complexity analysis for this solution. Let's do the time complexity analysis for this input. So for this input, how many iterations this for loop performs? 2 iterations. Correct. Basically, we have to process all the elements starting from the end of the array. Right. So if there are n elements, we have to process all the n elements in the array. So the time complexity is order of n. With respect to the space complexity, it is order of 1, because we are not allocating any additional space to store the intermediate data. Only for the final output we allocate space. So that's why the space complexity is order of 1. Thanks for watching this video. Have a great day.